Hi, young scientists. In the reaction we will perform today, we will look at the effect of changing the concentration of the reactants and products, as well as changing temperature and what effect that has on equilibrium. If you have your ChemStart kit with you, you will be able to follow along and do the experiment yourself as well. We will use the cobalt chloride solution for this investigation. Stay tuned. My name is Batabile from Kazimulo Applied Sciences, where we help young people perform science experiments themselves so that they can better grasp science concepts and do well in their exams and ultimately become confident scientists. We do this through ChemStart, a portable science kit that young people can use to do science experiments at home. If you are new to this channel, please like and subscribe so that we may notify you each time we post a new video every week. A reversible reaction is a chemical reaction where the reactants form products that in turn react together to give the reactants back. Reversible reactions will reach an equilibrium point when the rate of the formation of the products and the formation of the reactants is the same. There are factors that shift the equilibrium of the reaction such that either more products or reactants are formed by the reaction. When you change these factors, the rate of forward and reverse reaction are no longer the same, and the equilibrium then changes to a new set point, which changes the concentration of the molecules on both sides of the equation from the initial equilibrium point. Le Chatelier's principle states that a change in any of the factors that determine equilibrium conditions of any system will cause the system to change in such a manner as to reduce or counteract the effect of the change. An equilibrium constant can be defined as the expression of the concentration of the products over the concentration of the reactants for a reaction in equilibrium. If Kc is greater than 1, it means that at equilibrium there are more products present than the reactants. If Kc is less than 1, it means that at equilibrium there are more reactants present than the products. Concentration, pressure, and the use of the catalyst do not affect the equilibrium constant because the ratios of the reactants and products remain the same. The change in temperature, however, changes Kc because the ratios of the reactants and the products will change. So what you will need to perform this reaction is the cobalt chloride solution. It's the concentrated hydrochloric acid, the test tubes, the test tube rag, and the pasture pipette. And all these items are available in your kit. And for the investigation of the effect of temperature on the equilibrium, we will need the same solutions and an apparatus, which obviously are available in your kit. So let's perform the science experiment. So the experiment we're going to look at first is the effect of changing the concentration of the products and the reactants on cobalt chloride solution. Now these are the items that came supplied with your science kit. So you will have the test tube rag, the test tubes, the chemicals. What you will need to provide is the ice. I put hot water in this flask, and you must also provide the water that you're going to need during the experiment. You also have to wear gloves because you're going to be handling hydrochloric acid, and hydrochloric acid is corrosive, so you need to be safe, and you'd be wearing your safety glasses by this time. If your kit comes with a cobalt chloride solution that is already prepared, then you're literally set to go. But if the cobalt chloride solution has not been prepared, you'll prepare it this way. You will first dissolve 2 grams of cobalt chloride, which is this whole amount. You dissolve it in 25 ml of water. And then you add 25 ml of hydrochloric acid. Now this is concentrated hydrochloric acid, so it has some fumes which you need to avoid breathing. And we add this into the chloride solution. And it turns into a violet-like color. Okay. So now for the experiment, we need to add 3 ml of this cobalt chloride solution in each test tube. So it's 3 ml in here, 3 ml in there, another 3 ml in here. Okay, let's put our solution aside. It's also good to have a beaker that will have water that you can use just to rinse your pasture pipette. Now, let's look at the instructions. So now we've got 3 test tubes. Test tube 1, test tube 2, test tube 3. In test tube 2, we are going to add some water. And we observe what happens to the color. So when we add water, we see that the cobalt chloride solution changes into a pink color. Now let's look what happens to the same solution when we add the concentrated hydrochloric acid. The solution turns blue. Now, let's look at what happens if in the test tube where we added water, what happens if we add concentrated hydrochloric acid? You can see that the solution it turns blue. And then, what happens to the test tube where we initially added hydrochloric acid? What happens when we add water? So we see how changing the concentration of the reactants and the products has an effect on the cobalt chloride solution, or on the equilibrium of the cobalt chloride solution. Now we are going to look at what happens when we change the temperature. What's the effect of temperature on the equilibrium of the cobalt chloride solution? Now we are going to look at what the effect of changing the temperature is on the cobalt chloride solutions, on the equilibrium of the cobalt chloride solution. So I've emptied out the 2 test tubes that I used earlier, and I'm going to add in each, again, 3 ml of the cobalt chloride solution using my pasture pipette. 3 ml of the cobalt chloride solution. Cobalt chloride solution on all 3 test tubes. The test tube that's going to be, the test tube in the middle, I'm going to use that as my control. Now, in the first beaker, I'm going to add some icy water. And then in the second beaker, I'm going to add this hot water. I'm now going to put 1 test tube in the icy water. Oops. And the second test tube in the boiling hot water. And let's give them a few minutes and observe what happens. I mean, you can clearly see the difference between these 2 solutions. But now let's compare with the control and see if there is really any change in the equilibrium. So the solution on my left, the one that I put in the icy cold water, has turned a much paler color compared to the control. You can actually see that they are different colors, and obviously this one that I added in the hot water has turned into a nice beautiful blue color. So we can see that indeed the temperature has an effect on the equilibrium of the cobalt chloride solution. So now you'd be able to answer the questions that are in the manual. Be able to answer the questions in the manual, but obviously if your manual looks different to the one that I have, that is because I'm using a teacher's guide that notes all the observations and answers all the questions to that are asked pertaining to this experiment. I hope you enjoyed that, and the fact that you were also able to perform this experiment with me. See you in the next video.